For decades, humanoid robots lived only in our imagination. Stiff, clumsy machines stumbling across lab floors, forever almost ready. But that era is over. Right now, inside secret manufacturing lines in the US, China, and Europe, a new kind of worker is being born. A worker that doesn't sleep, doesn't eat, doesn't get injured, and never ever asks for a break. Humanoid robots are no longer experiments. They're being prepared for mass production. But as companies race to build these machines by the thousands, a far bigger question emerges. Are we actually ready for what comes after? A technological revolution like this doesn't creep in softly. It hits us like a tidal wave. And right now, that wave is forming faster than anyone expected. Almost every major tech company is involved. Governments are funding national robot strategies, and factories around the world are preparing to welcome their first non-human coworkers. This is happening. But the real story is why it's happening now.
For years, humanoid robots were too expensive, too fragile, and too limited to be used outside research labs. But recently, one critical shift changed everything: the hardware breakthrough. Robot muscles, high-torque actuators used to be incredibly expensive, making early humanoids cost well over $250,000. Today, actuator prices have dropped, sensors have become ultra-precise, and robotic hands finally have the dexterity to handle delicate objects without crushing them. The dream of a humanoid under $30,000 still isn't reality, but companies are closer than ever, with current prototypes landing anywhere from $30,000 to more than $100,000. These hardware improvements set the stage for something far bigger, and that brings us to the next breakthrough.
The second major shift, and the one transforming robotics forever, is the explosion of modern AI. Robots no longer rely on rigid, hand-coded instructions. They can now learn from human demonstrations, adapt to new environments, and make real-time decisions using the same large-scale AI models that power chatbots. This changes everything. A robot that can learn is a robot that can work almost anywhere. And then comes the third force, real market demand. With aging populations, persistent labor shortages, and a push to bring manufacturing back home, companies are struggling to find enough workers, especially for repetitive or dangerous jobs. Humanoid robots offer a universal solution. Machines shaped like humans, able to fit into workplaces designed for humans, without requiring new infrastructure or major redesigns. No overhaul, no new systems. Just plug in a new worker. Together, these breakthroughs are accelerating the humanoid revolution faster than anyone expected. We are witnessing a modern-day technology race, and the finish line is the first true mass-produced humanoid robot. In the United States, Tesla is one of the biggest drivers of this momentum. Their Optimus Gen 2 robot surprised the world with much smoother motion, faster speed, and highly improved hand dexterity. All of this is powered by AI adapted from Tesla's autonomous vehicle program, giving the robot an unusually advanced understanding of balance, motion, and decision-making. Elon Musk has even suggested that limited production could begin as early as 2025. Ambitious, perhaps optimistic, but no longer impossible. Next comes Figure AI, a fast-rising robotics company partnered with BMW. Their robot Figure 01 is already performing tasks inside a real production environment.
the company claims a milestone of the robot working 10 hours a day across several months in a genuine factory workflow. And then there's Boston Dynamics, long known for jaw-dropping agility and viral robot demonstrations. In 2024, they introduced a new, fully electric Atlas robot. This version isn't focused on acrobatics. It's designed for practical, heavy-duty work, signaling a major shift toward real-world applications. Together, these American companies have pushed the field forward with astonishing speed. But across the globe, another force is rising even faster.
While the United States is innovating at a rapid pace, China is scaling at an even more aggressive speed. Backed by major government funding and national policy support, Chinese robotics companies are racing to dominate humanoid production. Companies like Unitree, Ubkek, and Astribot are developing advanced humanoids while simultaneously building manufacturing lines capable of producing them by the thousands. This isn't just about innovation, it's about achieving scale, driving down costs, and reaching mass production faster than Western competitors. China's strategy is clear: reduce price, increase volume, and take the lead in global deployment. This has transformed the humanoid industry into a genuine international race with enormous economic and strategic implications. The competition isn't only about who can build the most advanced robot, it's about who can control the future workforce.
Building one impressive humanoid robot in a lab is difficult, but building tens of thousands of them, that is an entirely different challenge. Humans are unbelievably complex machines. One robot hand can contain more than a dozen moving parts, and a full humanoid includes hundreds of actuators, sensors, motors, wires, cooling systems, and precision-engineered joints. Scaling that level of complexity into mass production is something even billion-dollar companies are struggling to achieve. To make this work, robotics companies are borrowing strategies from the automotive industry. They're building modular components that can be swapped and replaced quickly. They're vertically integrating, designing their own actuators, chips, and sensors to reduce dependency on suppliers. And one of the most important breakthroughs is the use of digital twins, fully virtual robots and virtual factories where millions of simulated tests can run before a single real component is manufactured. In some facilities, robots are even being used to build the next generation of robots. But even with these innovations, the road to true mass production remains incredibly steep.
Despite all the excitement, huge technical bottlenecks still stand in the way of widespread humanoid deployment. The first major limitation is battery life. Most humanoid robots can operate for only 1 to 2 hours under heavy workloads, nowhere near enough for a full industrial shift. The second challenge is durability. These machines have never been tested in real factories for years at a time. No one truly knows how long the motors, joints, bearings, and electronics can survive continuous industrial wear. And then there's the question of safety. A 150-pound robot that loses balance or glitches unexpectedly can pose a serious hazard to human workers. Because of this, companies and regulators are now developing entirely new safety standards, certification requirements, and human-robot interaction rules. Before humanoids can operate alongside people in warehouses, factories, or public spaces, these systems must be perfected. The challenges are real, and solving them will determine whether humanoid robots stay in research labs or become a transformative part of the global workforce.
Some people imagine a bright future where robots take over the dangerous or repetitive tasks while humans focus on creativity, strategy, and higher-level problem-solving. Others fear a more difficult outcome: mass unemployment, widening inequality, and a world where opportunities shift faster than people can adapt. The truth may lie somewhere in the middle, but one thing is certain: the economic impact will be enormous.
Beyond the economics, humanoid robots raise a new set of ethical and social questions. These machines are covered in sensors, cameras, microphones, depth scanners, and environmental monitors, all collecting data, all the time. So who owns that data? How is it stored? And what happens when a robot records something sensitive or makes a mistake? These questions don't have clear answers yet. Privacy experts warn that humanoids could become a new category of moving surveillance devices. Regulators say we need strict laws in place before these robots appear everywhere, in factories, in retail stores, and possibly even in our homes. And then there's the emotional side. Many people experience discomfort when a robot looks almost human, but not quite, a reaction known as the uncanny valley. For humanoids to work safely and comfortably alongside real people, they must behave predictably, communicate clearly, and earn human trust. That challenge is not just technical. It is psychological, cultural, and deeply personal.
The technology is accelerating at a breathtaking pace, but our laws, ethics, and social frameworks are far behind. If humanoid robots are going to reshape the workforce, then society needs an entirely new foundation, a new social contract for the age of artificial labor. That begins with massive reskilling and upskilling programs, helping workers transition into the roles that automation cannot replace. We need modern safety standards for human-robot collaboration, ensuring these machines can operate safely, predictably, and transparently alongside real people. We need updated labor laws that acknowledge automation, AI decision-making, and the shifting nature of work. And we must develop clear rules for data privacy and accountability, defining what robots are allowed to collect, how long that data can be stored, and who is responsible when something goes wrong. This transition will also require better job transition support systems so that workers aren't left behind as automation reshapes industries. But perhaps the most important piece of all is giving workers themselves a voice in designing this future. These changes should not be dictated solely by corporations, governments, or technology companies. They must be shaped by the people whose lives will be affected most directly. Because this moment is more than an engineering challenge. It is a societal challenge, a cultural challenge, a human challenge. And the choices we make right now will determine whether humanoid robots elevate humanity or deepen the divides we already struggle with.
We are standing at the edge of one of the most profound technological shifts in human history. Humanoid robots will reshape factories, logistics, construction, retail, and even home care. The question is no longer if, it's no longer even when. The real question is, are we building a future that works for all of us, or just a future that works? Now, I want to hear from you. What excites you the most about humanoid robots? What worries you the most? And which job do you think will be the first fully taken over by humanoids? Share your thoughts in the comments below. Let's talk about the future we're creating together. And if you want to stay ahead of the biggest technological transformation of our lifetime, make sure to like this video, subscribe, and hit the bell icon so you never miss what's coming next.
The rise of humanoid robots is here. The only question left is, are we ready?